All right? So, we're going to start with a new equation today. A different kind of equation, not a rose. This is going to be a different shape. So, I'd like you to type in on your calculator, let's make it a little bigger than that. Let's say 5, no, let's stick with 3. That's a 3 minus 2 cosine theta. Now, how does that equation differ from the equation we looked at yesterday? What's different about just the way that equation looks? Well, did the equation we looked at yesterday have a sign in the middle of it? No. So this one's got this addition or subtraction. All right, type it in and tell me what shape, or what, take a look at that shape that you get.
These ones
We don't know yet. We're going to get a look at it. And hopefully you're going to determine that it is not a rose.
it's like a circle. It's like the other side of the office.
Okay, if you set your window at -5 and 5 for the x's and y's, you'll get a little bit more accurate picture. The picture you should be getting is something that looks like this. Now, I have it set at -5 to 5, so I'm right at the edge over here. And there should be a little bit of an indentation that you should see here. All right, let's try another one. Let's try this one. Let's try that one. See what you get with that one. Definitely not a rose. Would you agree with that?
An apple, maybe?
An apple? Wow, that's an interesting way of thinking about it. This one looks like this. Now, these are examples of what we call the Lima sign. And I always remember Lima sign by lima bean, because the shape is a lima bean shape. Now, if you want to call it an apple, that's fine, but apple's not part of that word, so it's easier for me to remember lima bean, Lima sign. It's a Lima sign. Now, I want you to make an observation about it. First of all, this is a cosine and this is a sine. They both have indentations, right? But the indentations are in different places. This bean is kind of sideways and this one is kind of upside down. That's the same as what we talked about yesterday. The difference between sine and cosine equations is not one of shape. It is one of rotation. Now, this one has an inner loop. This one did not. That has to do with the relationship of these two numbers. I'm not all hung up about that. I want you to know some of them have loops and some of them don't. But I'm not going to expect you to memorize a whole bunch of rules. The only rule I am going to ask you to memorize is, if you have a Lima sign and these two numbers match, they do not here and they do not here, like they do here. And they can be added or subtracted. It makes no difference. If these two numbers match, then you have a special Lima sign called a cardioid. And you might imagine that a cardioid has a more, what kind of shape? Heart shape, yes. So I will ask you a question. Is this a cardioid? And you will say no. because these two numbers are not the same. All right, that's your Lima sign. Next, let's graph this equation. Remember, there are 4 classical curves. We talked about this yesterday. These are the curves, big families of curves that the Greeks studied. 4 classical curves. One is the rose. We talked about that yesterday. One is the Lima sign. And the next one is an equation like this. Now, you need to tell the difference between these families of curves. So what did we already say? What's the difference between a rose equation and a Lima sign equation? What's the difference? How do you tell a rose from a Lima sign? The sign. There's a plus in there. 2 plus or 2 minus, right? There's a plus or minus in a Lima sign equation. A rose equation is 5 cosine 2 theta. Now, what's the difference here? How are you going to recognize this equation as being different? Yeah. This part looks like a rose, but you got an r squared in there. This is called a lemniscate. This is a lemniscate equation. And when you go to put it into your calculator, you can't put it in because the calculator doesn't say r squared. The calculator says r. So you need to put in 2 equations. You need to put in the positive and the negative square root. You need to bust this apart into its 2 square roots. So you're going to enter your lemniscate twice. Now, be careful. When you type that radical sign, a parenthesis comes in, right? When you type sign, a parenthesis comes in. Make sure you close those. And tell me the shape that you get when you put both of those guys in.
It's like an infinity symbol.
Okay, that's a way of thinking about it for sure. An infinity symbol. Anybody think of another way to describe it? I mean, that's fine. An infinity symbol is absolutely fine. Can you think of another way? Does anybody have another thought on how to describe that? I think of it as a figure 8. And this figure 8 is in quadrants 1 and 3. Do you suppose it's possible to have a figure 8 configured differently than quadrants 1 and 3? Yeah, if we change the sign to a cosine, you're going to get a figure 8, but what's it going to do? It's going to rotate it, right? It's going to reposition differently. Lemniscates look like figure 8s. Now, it's hard to tell because of the way that one's in the quadrants and not on an axis. But does anybody want to guess how long those leaves are just from the equation itself?
1.5.
They're not a half. They're 2. Why are they 2 units long?
Oh, because it's
Square root of 4. It's just like with a rose. Remember with a rose, this number tells us how long the leaves are? Same thing, only remember that's squared. So the length of the leaf is only going to be 2. Right?
And what's the 4 do? Does the 4 do anything?
The square root of 4 tells me it's 2.
Oh, okay.
Alright, so that's a lemniscate equation. It's going to be r squared. Now, you can make up your own equations, kids. There are zillions of kinds of equations. I'm describing only these basic 4 families, okay? Is your hand up, Zach?
Yeah. So for the lemniscate ones, I don't know what they're called. I'm dyslexic.
Lemniscate.
Where the 2 is, if you have like a 3 there, like a 5, like some odd number.
In a lemniscate equation, that is always a 2.
Oh, okay.
I didn't make that clear. It's
Okay.
always a 2. You could make it anything you want, but it would no longer be a lemniscate. It would be something else, some other shape.
Okay.
So you can graph. I mean, you can type in whatever equation you want and get some kind of wild shapes. We're looking at just specific types of equations, 4 of them. All right, so we got a rose, right? Those are the flowers. We got a limaçon, those are the lima bean heart-shaped things. And now we've got a lemniscate, those are our infinity symbols or our figure eights. Okay? The 4th one is probably the most fun to graph, but it's also the most complicated to graph. The 4th one looks like this. Now, how will you distinguish that equation from the other 3 kinds that we've got? What's missing in that equation? There's no function in it. It's r equals 2 theta. There's no function in it. So that's going to change the way I graph. Now I want you to listen to me. Remember, we're trying to learn here. If I put a sine or a cosine into the equation, then it is perfectly okay to go from 0 to 360. Because with sines and cosines, what happens after 360? They just start over again. So there's no point in looking at it anymore. You can if you want, but it's the same stuff. If I put a 0 in here, I get a value. If I put a 360 in, I get a different value. What if I put in a 500? I get a different value yet, right? In other words, there is no starting over point. Would you agree with me? It's going to be different. As you keep going, putting in different thetas, you're going to keep getting different R values. It's never going to repeat itself. So that means I got to make some serious adjustments to my window if I want to get a picture. Because if I only go to 360, I'm only going to get a little piece of the picture. So I'm going to suggest that you right now, everybody, put your calculator in radians. And here's why. I'm going to go several revolutions. And in radians, a revolution is 6.28. Right? In degrees, it's 360. So if I decide to go 10 revolutions to get an accurate picture, in degrees, I'm going to have to go to 3600, which is going to make my window humongous because then it's up to 7200. So I'm going to go to radians because the units are bigger and therefore I need less of them. Okay? So everybody's in radians, right? All right, I want you to go from 0 to 20 pi. And the step should be 0.1. If we're on radians, we're using 0.1. We're going to talk about that today, I promise. So everybody's gone from 0 to 20 pi, right? Step is 0.1. Now, what is the approximate decimal for 20 pi? 60 something. So let's set our x's and y's at negative 70 to 70. Remember, your x's tell you how much screen you're going to look at, your x's and y's. You are telling me we're going to, oh, wait a minute, time out. I need it bigger than that because theta is 60. So let's go to 150. Let's set our x's and y's at negative 150 and positive 150. Because I'm doubling it, right? I'm doubling theta in this equation. And then type in your equation and hit graph. And tell me what you get. You get a spiral. You get a spiral. And it is called a spiral of Archimedes. This is called a spiral of Archimedes. Notice, where did the spiral start? At the pole. This point right here is called the pole. It starts at the pole. And then it spins out. Now, what did we put our theta max as? 20 pi, which would be how many revolutions? 10. So your spiral should have spun 10 times and then stopped. Now, technically it doesn't stop, but you stopped it because you told it to go 10 times. That's what 20 pi did, 10 times. If you would have said 30 pi, it would have spun 15 times. right? Everybody got it? Okay. Now, let's talk one more time about why I set my x's at, what did I set them at, negative 150 and 150? I am graphing this curve. This is the equation I'm graphing. What is the biggest theta you're putting in? 60? So I needed a window that would accommodate 2 times 60? So I just said 150. Could I have used 140? Yeah. Could I have used 180? Yeah. I got to set a window that will accommodate 125 or whatever 2 times 62 is, right? Okay. Now, I want you to graph this one. Oh, wait. Before we do that, leaving everything the same, I want you to change your step. Instead of 0.1, I want you to go ahead and change it to 5. Change your step to 5. Hit graph and tell me what happened. It's got corners. It's got jagged edges. Would you say that is a jagged picture? Is it still kind of going around?
Yeah.
But it's jagged. Now here's what the step does. We haven't really talked about it. Here's what it does. If you are going to set up a table of values, if you set your step at 5, then that means you'll plot a point at 0, a point at 5, a point at 10, 15, and so on. The step is the difference between the points that you're plotting. Okay? Now, obviously, the bigger that difference is, the farther apart your points are going to be. And when you start connecting them, if you have, think of you had these points right here. If they're all close together and you connect them, you get that nice round arc, right? But what if I took out every other point? Now when I connect them, what happens? It's jagged. So the fewer points you plot, the more jagged and inaccurate your picture is going to be. Okay? So my goodness, then why don't we make a tiny little step? Let's go back and change your step to 0.01. Remember, we used 0.1 before. Change it to 0.01. Tell me what happens. It takes forever. Now, what's the upside of using a step of 0.01? You're going to get a beautiful picture. You're going to get a zillion points, and it's going to be a beautiful picture. The downside is it is plotting a lot of points, and it's going to take forever. So that is why I suggest, if you are in radians, usually 0.1 is fine. 0.1 gives you a good picture and not too much time. But if you ever get jagged edges, you're going to have to make your step smaller, okay? None of these should have jagged edges. So if you are getting jagged edges, your step has got to go down. Did you hear me? No jagged edges. Lower your step.
Why does 5 work when it's not?
Because in degrees, remember, in degrees, you've got 360 increments. A revolution, Jamie, in radians, a revolution would be from 0 to 6.28. That is one revolution. If you are plotting every 5, you're only plotting 1 point per revolution. If you are in degrees, you're going from 0 to 360. So 5, there's a lot of 5s in 0 to 360. So you're going to get a lot of points in a revolution if you're in degrees. Did you see the difference? Yeah, it's all about the unit, the size of the unit. Okay, now, next equation. We have one more to graph.
Ooh.
Now I want you to graph. Now, that equation looks an awful lot like this one, right? It's just a division instead of a multiplication. Is there any sine or cosine in here? No, so this is another spiral. This is going to be a different kind of spiral. Before you hit graph, though, I want you to think about this. I want you in radians, and I want you still going 10 revolutions.
So the max should be.
Okay? But I want you to think about what this equation is doing. Boys and girls, we're going from 0 to 60, basically. What is happening to your R values? Are they getting bigger like they were over here? No. So your X's and Y's are not going to be big numbers. Your X's and Y's are going to be little tiny numbers. Little tiny numbers. So make some adjustments, play around with it, and tell me if you can get a spiral. What did I tell you, 25? No. Yeah, 25.
I'm about 0.1 now.
All right, I got one. Anybody got one? Tell me what's happening. Is it a spiral? Those of you that are getting a picture, are you getting a spiral? What's different about it? There's something different about it, though. What's happening?
It's not. Starts from the outside.
It starts at the outside and spins in. This is called a hyperbolic spiral. And you are responsible for knowing the difference between the two types of spirals. An Archimedean spiral is the one that starts at the pole and spins out. It gets bigger and bigger and bigger. A hyperbolic spiral starts out and spins in. Is it possible for theta to ever be 0? In this equation, could theta be 0? No. So therefore, as this thing's spinning, is it ever going to touch that point right there? It's just going to keep spinning in closer and closer. Right? If you still don't have a window set up and you have simply got to be able to figure this out on your own, I used X and Y maxes as 0.1 and negative 0.1, and I got a perfect picture. All right, now I need you to get, oh, first of all, does this plate belong to anybody in this class? All right, I need you to get out your packet that I gave you for this chapter, and on the very front page are some old quizzes. We're going to go through these right now. Here we go. I gave you this packet a while back. Very first page has 3 little quizzes on it. There are 4 typos, but oh well. So here we go. Number 1, we're starting with the first quiz right up here in the corner. Number 1. The equation R equals 7 cosine 2 theta is a rose. You need to know that. I'm not going to tell you that every time. You need to know that's what a rose looks like. How do we know? There's no plus or minus, there's no squared, and there's a cosine, right? That means it's not a spiral, it's not all meniscus, it's all inclined. How many leaves does it have? 4. Bingo. Perfect. How long is each leaf? 7. A figure 8 is also known as a lemniscus. lemniscate. The origin is also known in polar coordinates. We call it the pole. It's called the pole. All right, underneath that is r equals 8 minus 8 cosine a cardioid. Yes. Why? Numbers are the same. A spiral that starts at the pole and spins out. Spiral of Archimedes. That's an Archimedean spiral. How many leaves does r equals 3 sine 4 theta have?
8.
How many leaves?
8.
8. In converting from, okay, now this is the old news here now. In converting from rectangular to polar. So think about if you had the rectangular ordered pair, which would be like 2, 3, and you were going to change that into polar coordinates. Remember what we do? I kind of gave you a hint here. It's automatic for me. What do every time? Draw a picture of it. Isn't this r? How do we find r? Pythagorean theorem. We know that x squared plus y squared equals r squared every single time. So if you know x and y, can't you find r? Yes. How do you convert from rectangular to polar? X squared plus y squared equals r squared. Other quiz. Draw a simple freehand sketch of a lemniscate. What are you drawing? A figure 8. Upside, it can be vertical, horizontal, diagonally, makes no difference. Figure 8. How many leaves does this thing have? 3. A spiral that spins in around the pole but doesn't reach it, that's hyperbolic. Hyperbolic. A cardioid is a special kind of limacon. Limacon. Turn it over. Turn the paper over. Number 1, what equals r cosine theta? X equals r cosine theta. Y equals r sine theta. You need to know that. Oh, we just did number 2. R squared equals x squared plus y squared. And what is tangent theta always equal? Tangent theta always equals y over x. Number 1, we're going to get to, we haven't quite done that yet. That's polar form. We haven't done that one yet. I'm looking at the next quiz down. So just hang on to that one for a minute. But we can do number 2. How many leaves does it have? The answer is 8. That's a rose. It has 8 leaves. Change 4, 100 into rectangular coordinates. This is a review question. You have r theta, 4, 100. We're going to change that into x, y. Go back up to number 1 on the top quiz. What did you tell me r cosine theta equaled?
So you do x is...
So if you want to know what x is, all you have to do is what? X is going to equal r cosine theta. And y is going to equal r sine theta. Caution, your calculator was set in radians to graph the spiral. So before you type this in, you better change it back to degrees. Because this is a degree measure. These are going to be decimals, and they're going to come out to be x and y. So what's x? 4 cosine 100 negative? Negative 6.9. And 4 sine 100?
3.93.
There we go. There's your x and your y if you gave me the right numbers. And then we are not ready for number 4 either. So right now 1 and 4 are out of our comfort zone. Okay, but we're going to talk about it. Now, you have some things you're responsible for, right?
Yeah.
What are the 4 classical curves? Rose, Lima-san, lemniscate, Spiral. Within that, there are a couple of other words I've given you. What's a cardioid? It is a special kind of a Lima sign. Now, when I say what are the classical curves, you're not going to say cardioid. You're going to say Lima sign. But I may ask you a question about a cardioid. And then within the spirals, I've asked you to know the two different basic kinds. You got the kind that starts in the middle and spins out. That is Archimedean. And then you got the kind that starts out and spins in. That is called hyperbolic. Okay? You know what the equations look like. If there's a plus or a minus, then the equation is going to be a Lima sign. If it's a squared, it's going to be a lemniscate. If there's no function, no sine or cosine, then it is a spiral. And the only other thing left is the gross. Right? Okay, so we're good on all that. All right, so here is really our last big task. Tonight you're going to be graphing. Okay? Our last big task in this little section is to ultimately, now we're not going to get to this today, no way, but ultimately within the next couple of days, we are going to be able to do this problem. I'll just put it over here to the side. This will be mind-boggling to you. We are going to find the cube roots of -1 plus root 3y. That's going to be our goal. Now, believe it or not, you're going to be able to do that. That is an imaginary number, a complex number, and you're going to find the roots of it. And if that's not enough, you're going to be able to graph the roots of it. Okay? But we have some background to do. That's the ultimate. So here is how this works. First thing that we're going to want to do is change numbers. Put that aside. That's kind of foreshadowing there. We're going to change a number like 4 plus 4i into what we call polar form. Now, this is different than what we did earlier. What we did earlier was take a point like 4, 4, and we changed it into polar what? Coordinates. Good. Now, there is a ton of overlap. By the way, polar coordinates, what do we mean? R, theta. There is a ton of overlap between these two problems. The math is going to be the same. The difference is, in coordinates, you have a coordinate, x, y, and your answer is going to be an x or an r, theta. It's going to be an ordered pair. If you start with an ordered pair, you're going to end with an ordered pair. What's different is this is not an ordered pair. This is an actual number. Like, think about when you solve quadratic equations. Don't you get answers like 4 plus or minus 4i? This is an actual number. So you are going to take this number, which is in complex form or rectangular form. This is called complex, rectangular, or Cartesian. All those mean the same thing. X plus yi, rectangular, Cartesian, or complex. You're going to take that number and you're going to change it into polar form. Now, what does polar form look like? Polar form looks like this. Now notice, what are the variables in there? R and theta. Now, to help you understand that, so it's not totally confusing, if I distribute, I get r cosine theta plus I r sine theta. What is r cosine theta? X. What is r sine theta? Y. See how it's the same thing? It's x plus yi, just written in polar coordinates, or polar variables. All right, so this is called polar form. This is the way we're going to answer our question. Now, if we knew R and if we knew theta, we'd be all done. We just plug those in and we'd have it. So let's come back to the given. What do I know about X and Y? They're 4 and 4. So I'm going to draw my trusty picture. Am I going to be able to figure out R from that? Yeah, just like I've always done, right?
Root 32.
So it's a square root of 32, which is 4 root 2. So my R value is 4 root 2. Now I need my theta. Now I think you should be able to do this without a calculator. You should be able to look at this and say, oh my gosh, those two sides are the same. There's only one kind of a right triangle that has two sides that are the same.
45, 45.
So that angle is 45. Now, if the numbers had been some weird things, you would be doing it on your calculator, but this one I think you should be able to get without a calculator. So theta is 45. So I write my format, which is R, parentheses, cosine theta plus I sine theta. That is called polar form. Your job was to change it into polar form. So our R was 4 root 2, and our angle was 45. You are allowed, this is polar form, but you are allowed, if you wish, to write it like this. That is the shorthand notation for polar form. This is polar form, but you are allowed, if you wish, to use the abbreviation, the shorthand. What do you think CIS stands for? Cosine I sine. So we're going to be writing a lot of these numbers, so I am perfectly okay with using the shorthand, as long as you understand that it represents this. Okay? All right, let's try one more. I want you to change let's say negative 2 minus 2 root 3I into polar form. So you're going to do the same thing now. We're changing into polar form, which means we need to find what? R and theta. What have we been given? What are these two numbers? X and Y. So I'm going to go ahead and draw a picture of that. X, Y. Complex numbers are X, Y, X, Y, X plus Y, I. So what's my R?
Would that be 4?
That would be 4. 12 plus 4 is 16. That would be 4. Now again, this is one where I would hope you wouldn't need a calculator. I would hope at this stage of the game, you would look at these ratios and say, whoa, wait a minute. There's a 2 root 3. That's double that. That's a 60-degree angle. How do I know it's 60? Because it's across from the root 3. So what is my polar form? Be very careful. 4 CIS or 4 if I write out longhand. What is my angle? Be careful. What?
Is it cosine 60?
No, it's not 60.
30.
There's theta.
Oh.
Theta is always measured in standard position. And in polar form, theta must be positive. So this answer, when you put an angle here, it's always going to be positive, and it's always going to be within 0 to 360, or 0 to 2 pi. So what is it? 240. Now, we're gonna talk more about that tomorrow. This is your longhand. If you wanna write out the actual formal fuller form, this is your shorthand. Both are perfectly okay. We'll talk more about this tomorrow. We have a homework assignment for tonight. I expect you all to do it. So that when you come to class tomorrow, you are fully prepared for whatever awaits you.
What is the?
Yes, the homework is in the